Coffee.
Alrighty, welcome everyone to today's Passive House Alberta Coffee Talk. My name's Frank Crawford and I am the Education Committee Lead for Passive House Alberta. Today we're going to be talking with Kevin Brown and Christina Herbers about the design and mechanical equipment selection for a cold climate commercial passive house in southern Alberta. Kevin is a certified passive house consultant and tradesperson, and he has been working in the high performance construction industry for over 20 years, and is currently one of the founding partners of Think Design Consult Passive House in Calgary. Christina is a professional mechanical engineer and lead AP with over 20 years working in the high performance mechanical systems sector, and she is currently an account executive with HVAC Systems and Solutions in Edmonton. So please put your questions in the chat box. For now, make sure you're muted, but at the end, you can either unmute and ask the questions, but the questions will be left to the end. And with that, Kevin, take it away.
Well, thanks very much, Frank, and welcome everybody. Hello, Christina. I'm looking forward to this. So yeah, the project was a passive house agricultural processing center against the Southern Rockies. And so a little bit challenging geography, altitude and not incredible south-facing exposure, but yeah, it's on we went, and it's a client build as well, which is very interesting. So I'm going to just run through the presentation here. I've got about 12 minutes if I can keep it to that. Kevin Brown likes to tell lots of stories, so who knows. But if I can keep it to that, that's great. Then Christina will be on to dig more into the ventilation system that we got installed. And then hopefully we've got some time at the end for some questions. So first, where was it? Well, that little green blob at the bottom part of Alberta, it's in the extreme southwestern portion of that. So it's against the Southern Rockies, close to Waterton National Park. And so it's nice, and compared to the rest of Alberta and the rest of the prairie provinces, it's actually relatively warm, but it's still in the Passive House cold climate zone. And the other question that the client had that we, through discussion, we went, okay, well, it's to be future proofed. The building is planning to be a processing center for agricultural products. So it's a glorified barn with some office space, and they wanted it's to be off-grid. They want it off-grid electrical building, and they want it to be future-proof. So the client very quickly gravitated towards Passive House because of the fact that we build a very well-insulated home with proper shading and close attention to detailing. It's not only good in the cold, but it's also good in the heat. So this is nice from the point of view of heating in the winter, this change. But of course, from the point of view of keeping cool in the summer, it becomes a bit more, well, just a tad trickier to move an entire heating degree day zone. That's a big chunk. So we'll see what happens there. So with that as well, the client was interested in looking at the health and comfort, quality improvements. If there's partners and employees in the building, he wanted everybody to be quite happy with the workspace. I wanted to look at a reduced cost of ownership, and it is going to be, Passive House plus fully net zero. It's going to have enough of a solar array and battery backup system to allow it to skate through the winter without wanting for power. For who the client also has children. This is my granddaughter. This is my inspiration, and Lily lives in Regina, and Juliet lives with us, and both of them. It's a large reason why I do what I do, and the client has children and grandchildren as well, so they're concerned about more than just the energy bills. So it was also very quickly had talked about energy efficiency, wanting to be off-grid, wanting to reduce the cost of an off-grid system. And then as I was talking more with him, he very quickly became attracted as well to the comfort metrics of Passive House. And in Passive House, we do, of course, design for very comfortable internal spaces. And those can be quite well defined in terms of what we want in terms of air temperature and humidity. That's the easy stuff. But I always find it remarkable to figure out what it is that people tolerate in terms of drafts, and less than 0.08 meters per second in terms of airspeed. Any more than that, and people find it drafty. Also, the vertical and horizontal stratification of temperature, people just don't like it if their toes are 2 degrees colder than their head. They really don't like it. Surface temperatures have to remain up above 4.2 degrees difference from that interior temperature. And so those metrics are very important. Now, in the passive host system, though, it's an energy standard, and we pay attention to all these things when we're designing. But the metric that you actually want to meet is the heating demand, heating load, and the primary energy renewable use. And in this case, because it is a fairly large building with not an incredibly simple shape, and only so thick you can make the walls in the end. We're aiming towards a passive house low energy building in terms of the performance standard. The building shape isn't all that complex. It looks better in plan. There's a garage off of either end. So the garage with a shallower foundation, there's one on either end of the building, and those aren't included in the thermal envelope. And so what is included in the thermal envelope is really quite a simple space. We can see, though, pardon me, there's production areas and washrooms either side with storage and office space, a main production area. And one of the partners in the business wants to, would like to explore doing food production as well. So there's a fairly decent sized kitchen. The gray block on the left side, I'll point out, that of the kitchen is a wood stove, which is kind of a last resort, final backup heating system. You can see the blue windows are in the north, the red windows are in the south, and we've had some very robust discussions about balancing the windows from north to south. And but if anybody's familiar with the Southern Rockies, you know that the money views to the north and the west, right? You look towards the mountains, sure, but from their property, it just so happens that if you look towards the mountains, you see some peaks way off in the distance, very small. But when you look out towards the prairies, towards the north and the west, then you get a very spectacular view. So as a result, the orientation of the building is towards the north and towards the east in this case, in order to take advantage of those views. Now, it's still within the realm of reason to have sort of decent solar exposure. And I didn't include a view of the other side of the building till later, but even though you see that there's not large overhangs on the north side, on the south side, you can see that line down below, there's quite large overhangs. So it's nicely sun protected in the summertime. Following the bouncing ball through the passive house, 5 principles for energy efficiency. This is all important stuff. I'm going to take it for granted that most people on the call are familiar with this, but if we make sure that we have good insulation, thick insulation that's continuous all the way around the building, then we're doing really well. So there's the wall system is got mineral wool on the interior. That's actually a structural wall. If you can see, there's a 2x8 wall in the center that's full of cellulose, and we want to skate that over the foundation a little bit. So there's 3.5 inches bearing there. But because of the fact that it's a 5,000 square foot roof, basically, the engineer demanded that interior 2x4 mechanical chase wall also be structural, which, okay, that was fine. So the interior 2x4 structural wall, mineral wool insulation, and then Intello Plus membrane in behind it, 2x8 cellulose, and then the outside 3.5 inches of mineral wool, and that gets us to a U value of 0.105, which was pretty decent. Foundation was conventional 8-inch concrete with 8 inches of graphite polystyrene on the outside, glued to the foundation, and then with dimple wrap. And then above any part above ground also had a stucco finish applied to the outside on top of some plywood, so dimple wrap could be continuous right underneath the floor plate all the way down. Went for scissor open web, not scissor, but open web trusses for the flooring system, and that allowed him to get the ventilation system in place very handily. So we'll talk more about that. The foundation wall to floor slab, this was a fun thing we ended up finding out through energy modeling. I'm always nervous about having a footing against the soil because quite often in passive house, we put foam underneath there, we insulate the soil. But what we found with some thermographic modeling is that if we had 2 inches, well, and what we actually modeled was 1 inch, and I said, well, give her 2 because you've got 4-inch leftover material from doing under the slab. So just slice that in half and do 2 inches of foam all the way around the outside. That ended up with just fine interior temperatures and no problem with the thermal bridging. So the wall to foundation and the foundation to slab corners modeled out really nicely. And the foundation to slab corner was actually done, if you can see in the top graphic of the thermographic image, and now on the left, that's the window well. So that was modeled at the most vulnerable part of the foundation. And so internal temperatures of 15.96 degrees at 20 above, 20 degrees interior and against the ground temperature. It worked out just fine and was really good. The SASIC label is there because Marshall Gardner of SASIC did the thermographic modeling for us, which was wonderful. He was great to have as part of the crew. With the windows and doors, we used Initech Cold Climate certified windows, and that is really important to get really good windows in a building. But and these are great. The client was very happy with them, and they came in at a price point that was decent. And yeah, even though they were ordered just at kind of the tail end of COVID, they arrived on site in a decent period of time and were installed nicely. So yeah, but I go on and on and on and on ad nauseum about Windows because it makes such a huge difference. Frank actually has a wonderful photo of him and his 2 sons lying down in a window seat when it's obviously winter outside the window, and they're perfectly comfortable in the window seat right beside the window. And indeed, that window seat remains comfortable throughout the winter. And if you live in a house or a building, you work in a building that's not a passive house, you know how unlikely the graphic on the photograph on the left is in the middle of winter in Alberta. IntelliPlus membrane, and again on the inside. Just before we start the slideshow, we were all having a bit of a chuckle about how your first blower door test ends up being perhaps your best one because you're so you're so worried about it. The client took on being the air boss himself and did all the air tightness on the envelope and the interior airtight vapor barrier system, and got a really nice result. And also he paid attention as well. The exterior air barrier was the primary place where he could get an airtight layer against the ventilation duct because of the installation condition of the way the vents came out of the floor from the ERV down below. And so it became, he did seal the inside, but he managed to be particularly meticulous on the exterior. And I read him the riot act on making sure that both layers were nice and airtight with Soltex ProClimate Soltex Menta 1000 and IntelliPlus on the inside. You've got an envelope that's breathable both ways. And then you can see the mineral wool insulation tacked onto the outside, ready for the strapping. And then getting to the meat of it, the ventilation. We ended up with a building the size of which I'm more a small building person, but if you're talking about a larger building, so 5,000 square foot building, it's not, as huge houses go in southern Alberta, it's not gigantic. You end up having to use a larger, more commercially oriented ERV product. And so we went with the Swegan Gold RX7, which is not a gigantic machine itself. Now, the Swegan Gold, it's not a, it's an ERV, but it works with the enthalpy wheel. And I'm going to allow Christina to go on more about the technology, about how that works. I just call it the magic wheel, because even though it's rotating slowly and it's trading the warm air that it gets at the bottom with the outside air at the top, it is really quite efficient. I believe this measured out at installed, including duct losses and everything, it measured out at about 86% efficiency, which was really quite good. Now, of course, it exchanges not only heat, but also moisture. And the moisture is around 82% efficient or so. Which means you can't use it to humidify a space in the wintertime in Alberta, but you can temper it. And so you don't have to add near as much humidity to the air after the fact with an ERV. So it's a real no-brainer for our climate, our dry climate in the winter. Yeah, and I actually attended a HVAC systems webinar that I was trying to place the date of that, but I believe it was in 2020. It was one of the earlier webinars that HVAC systems came out with when they had announced that they were producing the Swegan line in their factory in Toronto. And my first question was, well, what happens? Like, all this is doing is turning around slowly. So what kind of cross-contamination do we have? And it is rated for use in hospitals. So it works remarkably well. With the ventilation system, it was planned to meet Passive House standards. So you do your 3-part test, and indeed the volume of the building with a volume adjustment in the circled part of the building, because of that high voltage space there, we wanted that fully ventilated, mainly to keep heat gain under control if there's people working in there in the summertime. So that's how we came up with our cubic meters per hour CFM rating for the system, and how we ended up sizing the Swegan RX7. Once I had done that, I did some plots for a mechanical engineer who could then go over all the static pressure losses. And so we did plots for the exhaust as well as the supply duct lengths. And then we overlaid that on an accurate plan with the truss layout ghosted in the background. If you recall from that, that wasn't an accurate drawing of the open web truss that I showed you before, but we did have accurate data, from the shop drawings from the truss system. So I was able to confirm where this was going to work and where it wouldn't. So it helped the mechanical installers to do so. When it came to heating, what we did is we, and HVAC system supplies with our heating system as well. What we did is we went to LG multi-F heat pump system. It's a mini split system. We did consider putting a coil in the airstream, but this is going to be a less expensive and possibly more efficient solution. So there's one outdoor 4 tons, so about 48,000 BTU capacity heat pump on the exterior with a distribution block running to 4 heads, and one in each of the main floor offices, one in the there's a office in the loft space, and then one in the kitchen, and that was going to be sufficient to blow some hot air around and some cool air around as well. And then depending on the ERV, to do some heat distribution force to the rest of the spaces. Backup heat when the cold climate heat pump wasn't going to be able to operate. Baseboard heaters in all the offices, and fan forced heater if required in the other main spaces. which could be that you can install those fairly easy. Baseboard heaters are cheap as chips, and they're great backup. And all electric for this house was the best way to go. And then a wood cook stove. There's not that many wood cook stoves on the market. This one is an Italian make, but the key to it is that it has a separate intake for the combustion chamber out the back of the stove. So insulated duct leading into the combustion chamber. So it becomes a closed system, with the exception of the time you have the door open when you're lighting it. So it's a very, very efficient. That's really what you have to do if you want a wood burning appliance in a passive house. But all the way through, we're paying attention to the fact that passive house is a whole building design. So a very efficient TRV meant, and very good windows, and paying attention to thermal bridges and air tightness, and allowed us to make up for whatever issues we had with solar cell. So that's about it from my point of view. Think Design Consult, it's a collaborative design practice made up of architecture firm, mechanical engineer, and myself, and yeah, we're having a lot of fun. So what I'm going to do is stop my share and pass it over to Christina, who can go on. And I didn't quite make the 12 minutes. Sorry, Christina.
Yeah, that's okay. That's okay. Thank you, Kevin, so much. Yes, I'm Christina Herbers with HVAC Systems. I'm just going to share my screen really quick. Yeah. Then we're going to hide everything.
Is that you on your off hours?
Wait. Why isn't everything working? Oh, there we go. That is my daughter dancing. Yeah.
Wow.
Yeah. So, okay, and I want to hide this one. And okay, maybe we'll just have Kevin in the corner. Okay, so yes, Kevin mentioned most about this project. So yeah, I worked alongside Kevin. Wanted to quickly do a land acknowledgement. So we're on the traditional territories of Blackfoot, Stoney, and Métis Nation, and the land of all the people that make their homes in Treaty 7. So yeah, I'm Christina Herbers. I've kind of how Kevin mentioned his grandchildren. I've also kind of wanted to focus on green and maybe not green engineering, but something different than status quo. So I got my BSc in mechanical engineering in 2000. I spent 10 years specializing in district heating and district cooling systems mostly throughout Canada and the States. And then I moved to some Salem consulting. I did some water treatment and wastewater treatment plant designs. And again, these were we always tried to integrate solar PV or solar thermal or something to help with offset the energy usage of those buildings. I got my LEED certification in 2010. And then for the past 5 or 6 years, I've been really focusing on energy recovery from ventilation systems. I'm very active in ASHRAE, Northern Alberta. I'm the president-elect, so next year I'll be the president, and I'm really passionate about diversity to ASHRAE, which is women and people of color representing in our HVAC community.
Christina, can I just jump in quickly? Can you go on your display settings and swap presenter and display view?
Okay, where do I do that?
On the presenter, on top of your black screen, display settings.
Display settings.
And then swap.
So I have participants chat, new, share, pause, summary, stop video.
Go to the top there. We're just seeing the presenter view and not the slide view. Up, display settings at the top of that screen.
I don't have display settings. You're sharing your screen? Sorry, guys.
That's okay.
I don't see it. Is that
Okay.
the bottom?
No, it's at the top on your
I've got-
PowerPoint view.
I've got mute, stop video, security, participants chat, new
No,
show.
it's not, sorry, it's not on Zoom, it's on your PowerPoint.
Oh, okay. Oh, my
So-
PowerPoint. Okay.
Yeah.
I
So
can
it-
go, I can, here, just a sec. I'm gonna stop and I'm gonna share my other screen.
Yeah, that'd be the other way to do it.
Okay. All right. Is that better?
That looks perfect.
Okay.
Thank you.
Except for the top.
No, perfect, carry on.
Okay, awesome. Yeah, so HVAC systems, we have been specializing in zero emissions passive house buildings for the past 23 years. We have 5 offices in Western Canada. Our head office is in Vancouver, and we represent over 30 product lines in Alberta and over 50 in BC. So we've got our president Jivan Thacker in our Vancouver office, myself, Kyle heads up our Calgary office, which is fairly new. And then Rodney Cornell is our inside sales supporting us in Alberta and BC. So today we're really going to talk about the Swagon or Swegon, whatever way you want to say it. But that's what I'm going to go through. And maybe you can't. Oh, maybe you can't see the top of my screen, but these are over the past 3 years. These are the Swagon projects that we've installed, the ERVs in Alberta, Yukon, Nunavut, and Northwest Territories. So can it work in cold weather? Yes, it can. And there's several more that are also currently in design with engineering firms throughout Western Canada. So, and today we're going to dive into the Southern Alberta Processing Center. I'll just skip over that. We have lots of products. So Passive House, Kevin went through the 5 different building strategies for them. And what I'm going to focus on is the, continuously balanced ventilation with high efficiency heat recovery. And this ensures fresh air and helps control the moisture. Like we said, when we've got that tight insulation, we've got an airtight building envelope, the ERV really becomes the lungs of the building. Investing in a high quality system with both latent recovery and sensible recovery of that heat, so your dry air and your moisture, makes a big difference to your building. Actually, for a passive house building, you have to have a higher than 80% efficient ERV unit, which Swagon is certified units, both commercial and we have some smaller ones as well, I'll show you. And so why is that important? Again, so about 40% of CO2 emissions come from building energy consumption, which, as we know, poor indoor air quality can lead to poor work, poor learning performance, and providing high quality filtered ventilation is just better for occupants in the building, as we all know. He mentioned already kind of where this is, so very, very southern Alberta, really close to the border. He mentioned the usage of the building. We HVAC Systems got involved in the design in 2021. So we were happy to work alongside Kevin. And when he approached me, he said, the design intent is the net zero building. He was going to use the tool of the Passive House Planning Program. I mentioned it have to be a Passive House certified ERV. And the winter outdoor design air temp, I believe, was minus 24.1. So I just put this little blurb here, design like the year's 2050. Let's start designing for that today. Why wait until things potentially get worse? So initially we were just talking about ventilation with the ERV. And then as we looked into it more and more, we realized that, or Kevin was stating, you know, forest fires and heat domes are getting to be very common. And in passive house buildings, they typically have a higher cooling load than compared to typical construction. Again, because of that air tightness and kind of whatever heat is created in the building seems to stay in the building. So the chosen system was a Swagon Gold RX ERV with an integrated heat pump. So he is correct that we originally were going to put it was going to be a single VRF, and then at the end it was split out. But yeah, with Swagon, so this can all be done at the factory level. We can build in your VRF's heat pump system completely designed at the factory level. So yeah, so it's really a fully integrated design, and the controls that are built into the unit will control that VRF unit. And again, the brand of heat pump doesn't matter. It can be compatible with many different types. And then, so why would it be important to see a passive house certificate for the HVAC equipment if you're pursuing that passive house rating? Well, the passive house certificate confirms that the component's been tested at the Passive House Institute in Germany. And it confirms that the certified heat recovery rate is accurate, and it's been tested. The efficiency of the heat recovery rate, the electrical power consumption in watts per CFM, the air tightness is an acceptable level. Kevin mentioned that. And the indoor air quality, the filtration levels are of the acceptable level, and the sound levels are of the passive house. So really keep that in mind when you're doing your projects, that Passive House Institute certificate is really important for your mechanical equipment. Yeah, this is just kind of a zoom in of the unit here. We actually went with top discharge of the unit. The original design was side discharge, and then the more we looked at getting it into the space, we needed top discharge on the unit. So the design was modified about 6 months in. So both of those options are available to you when you're doing other future designs. You can also place the unit indoors or outdoors, and I'll show you a picture of an outdoor one later. So yeah, for Rocky Mountain Agricultural Processing Center, for ventilation and energy recovery, we had a 86% efficient Swagon Gold RX07 ERV. That was our central unit. And then for heating and cooling, we had that 4-ton heat pump, which was LG. And then originally it was a split system, and it was just slightly revised in the end. And then the backup heat is electric baseboard heaters along with the wood stove, as mentioned before. Now, yeah, I wanted to show you. So how does it work in our cold climates in Alberta? So the Swagon Gold ERV is designed for these temperatures, -40 to +40. We do suggest a small electric or hot water preheat coil below -20 degrees C. But in colder conditions, if there is any, so you have that preheat coil, but if there is any frost buildup on the wheel, the enthalpy wheel will slow to a speed of 0.5 RPM using a stepper motor on the wheel. And it'll give the wheel longer in the warm airstream to remove any frost on it. And then it will continue operation. And this is all automated into the unit. So it'll sense that outdoor air temperatures and continue. The ERV casing is also 2 inches thick and double wall insulated. And if you are putting your unit outside, you can put in an outdoor weather roof kit. Here's a photo of an outdoor mounted unit on posts. So in this case, we put our unit indoors, which is great if there's going to be space in that room. But another option is to put it outdoors. So we're one of the smallest footprints on the market. You can downsize your any other additional cooling. You can downsize your humidifier. So this is providing stage 1 of your heating and cooling with your highest enthalpy rotor efficiency. Yeah. As I mentioned, so this is kind of the brains of the Swagon ERV unit, is the IQ Logic controller. So this is going to be correcting your airflow for airflow density and filter loading, maintaining constant airflow volume. So maintaining a proper air balance in your building. And it's simple and easy to set up controls, easy to commission and use, and it allows high control of your unit. So really it's up to you as a designer as to how you want to control the airflow. And then we have up to 1,700 control points. So you would tell us, oh, this is how I want to control the airflow in my building. And that's obviously for a centralized system, but you can also go for decentralized Passive House certified units if you would like. If let's say you have a multi-story building. So we have those at Swagon as well, and HVAC systems. And these are Passive House certified units from 60 CFM up to 1,000 CFM for a more decentralized unit. Another option we talked about for this job, but we didn't end up doing it, is demand control ventilation. So at each of the rooms, let's say in this case, I think we only have what, six or 8 rooms. Let's say you have more than, let's say your central unit is controlling maybe more than that. You might want to do demand control ventilation, which is putting Swagon React dampers at each of the spaces. Again, you could do this on the supply side or both the supply and return side. And that way, if there's no one's in that room, no one's occupying that space, you don't have to ventilate it or, provide conditioned air to that space, as that's just going to cause, unnecessary cost of energy. So for more resources, we've done over 200, I think, Passive House certified projects in BC, and we've done several in Alberta. So visit our website. I wanted to advertise there's a Red Deer Passive House course for any installers coming up in Red Deer, and that is all I had for you guys today. So any questions, just put them in the chat.
Great. Thank you, Kevin. Thank you, Christina. It was an excellent looking project. Good to see a cold climate commercial building built in Alberta. All right. So I guess anyone on the call, if you have any questions, feel free to unmute or I can read them for you. So we got one from Celia. Are the decentralized ERV units also rated for exterior installation? Would the units be appropriate to be installed in an attic surrounded by loose fill cellulose?
They are for indoor installation, but an attic would probably be okay. Yeah, send me a message on that, and I would definitely love to take a look at that with you.
Yeah, you still have to make sure that you have access to clean your filters. So yeah, you'd have to make sure you can still get to the filters because those need to be cleaned.
Yeah, I have a lot of them installed in ceiling spaces, so you would access them with a ladder, or pop the tile out and access them. So yeah, as long as there's access to this space and it's insulated, then yes, we place these indoors, the smaller ones.
Okay. You could, if you're tight for space, then it wouldn't be a bad idea to put it in the ceiling and just create a box in the attic and insulate around that box. So that is another option for that kind of a situation where, you really want it up and out of the way. Well, that's the way you could deal with that.
Mm-hmm. Another nice place is the like the laundry room. There might be extra space and just a cabinet that where else have I seen it? A closet.
Above fridges.
Yeah.
Depends on how big your square footage is. If you think back to the slide that Christina showed of the decentralized units, the smaller capacity ones are quite compact, and as they get bigger, they get bigger. So depending on the square footage of your space and what you're looking, the space you're actually looking to ventilate.
Yep. All right. So another question. Any comment on how much higher? Oops, sorry, I lost my core. One sec. Any comment on how much higher the costs are for total ownerships of these ERVs? Does this change with the heat pump addition, assuming the heating load has been reduced through insulation? So I guess it'd be more is there a big cost premium of these Passive House certified units versus just a off-the-shelf unit, and is the efficiency improvement kind of pay that back, or kind of along those lines?
Kevin?
Take that one.
No, So
I remember the graphic that I showed, the whole house system. So it is the habit in Canada, I believe, due to 40 years of federal government programs where we're presented with a shopping list of energy efficiency and pick little bits here and there. It really is a whole building analysis. So when you're talking about the payback or the cost of ownership for this kind of gear, you really have to look at the whole house operating together. So that's one point. The other thing is that these systems are not high airflow, right? We're talking most passive house ventilation systems. If you take the back of your hand and put it a foot above the duct on your average size living space in a house, and you feel for the airflow, you can perceive it. Yeah, it's there, but it's very low flow. High efficiency ECM motors, low flow systems, low load systems. It's common to think your ventilation equipment is going to last 15, 20 years. And this type of gear, it's going to last you 30, 40, 50 years. The other thing about the most passive house rated appliances is that they're field repairable. You can replace all the major components. The box is going to last forever. So it changes the combination of efficiency, increased comfort, and the low maintenance costs. It changes that idea of what your real benefit is. So it changes the finances of it. So you do pay more for a passive house certified unit. But when you're talking about the whole life cycle costs and you combine that with the health and comfort improvements, it makes really good financial sense.
Yeah. And you could also, it's just an energy model, so you can get the actual efficiencies by a third-party certified party for each other different piece of equipment and put it into the energy model and see what that difference is and see where you have to make up the lower efficiencies somewhere else, and you can put cost to that. But yeah, we found that, yeah, you want to get as high efficiency as you can. The cost generally does pay back.
And the payback would be shorter for a higher efficiency unit. So maybe your capital is slightly more. Again, I'm not talking a lot more, but your payback over time is going to be quicker with a higher efficiency unit. That's pretty straightforward. But yeah, we can look at that exactly if you wanted to send me the size that you're thinking of, and I can look at that.
Okay. Two other kind of questions that are similar. So I guess HVAC systems, Christina, do you guys provide the mechanical design, or is that done by someone else and you just assist from there? Do you still normally have a mechanical designer or a certified passive house consultant providing you those loads?
Yeah, so Kevin was our customer on this one, and myself and Rodney in our office, we are both engineers, so we will definitely help with the design. As far as stamping the design, that's what he was mentioning, that we both of us got a third-party firm to do that stamping of the ducting design. But we will absolutely help with the design of the unit. We'll provide the AutoCAD, help you with AutoCAD drawings, the specifications of the unit, the written specifications. Yeah, we are part of your design team for sure. And I don't charge you any money, so.
Perfect.
Yeah, it was
Joe,
great to be able to depend on the expertise. So
Joe, you got your hand up. You might as well unmute.
Thank you for this. I'm in an 8-year-old house. It has it's new Canmore based. I'm thinking of installing a heat pump to augment the heating system, especially given what I know is going to happen in natural gas prices when the LNG pipeline opens. Do you have any recommendations? Currently, I have the HVAC system, which is thermal for the basement floor and forced air for the house.
Kevin, do you want to go ahead?
well,
Or-
Frank has a considerable amount of expertise in that
Okay.
area too. But with your forced air heating system, you do have an option of holding on to it and then putting a coil in the unit so that any natural gas you're using becomes your backup heating. But you can depend predominantly on a heat pump where the fluid, instead of going to an indoor mini split head like I portrayed there, it goes to a coil that's part of your forced air furnace system. And so you end up with fairly effective distribution of both the heating and the cooling as well. That's a really nice thing about a heat pump. It's not only heating, you're covering yourself with cooling, which is great in our ever warming summers. I mean, so yeah, that's one option. And that option, you're using current ducting, it fits quite nicely into that. It depends on what kind of ventilation system you have. And so, again, it's the shopping list of energy efficiency improvements. And the grants have been really heavy on air tightness over time. So what I tell clients, I say, look, chase after the obvious leaks and then install an ERV system as fast as you can. Get proper ventilation happening in your home. So when you're talking about that, then the use of the current ducts, particularly if you already have in-floor heat, it changes the conversation some, but it can go in hand with other envelope improvements. So the problem with me answering a question like that is I always have that Venn diagram of the whole house in mind. So you say, well, how about a heat pump? And I'm going, well, what are your windows like? Right? That's where I go.
This is a well-built 7.5-year-old home.
Mm-hmm. So it's probably okay thermal performance. You probably don't find it horribly uncomfortable.
No, in fact, huge windows and it's never cold. Yeah. So the second half of that question would be, would you undersize the size of the heat pump so that it doesn't have to provide all of the heating, but the majority of the heating and cooling? Or does that make any difference?
I mean, you could do that, but really we typically size them for the your highest of your heating or your cooling load. So you kind of look at you look at your heating load, you look at your cooling load, and then you size it so that it has capacity to do that. If you were going to keep your existing system as more of a backup, then you could technically downsize it, but like you're saying, if gas prices are going to go up, you want to have the capability in 5 years or whatever to use you don't want to have to replace it again. So, we could give you different options for sure. But yeah, I think instead of downsizing it, I would try to accurately size it for your needs.
Last question relates to the very thing you identified, which is changing summer temperatures. The heat dome was 38, 39 C here in the Bow Valley. What sort of climatic norms are you guys currently using as your projection base?
Well, the building was modeled using Passive House planning program. So it's a bit of a departure from how things are traditionally done. So basically, we very thoroughly count pretty much everything and then follow from there. The heating loads are then derived from the coldest expected temperatures, and those temperatures are derived by looking at the climate record over, since we've started keeping temperature records in Alberta, and it averages out. So in terms of cooling load, you want to, like Christina said, you want to cover your cooling load, and you might want to add a little more because of rising temperatures. In terms of your heating load, the model, what it models out at for Calgary, it'd be a little bit colder in the Bow Valley, and a little warmer down south where this project was. But it's about 24.1 or so degrees is the coldest temperature the cooling load is based on. The coldest average temperature. Okay, so with that, you got to cover the -38. So what the guidance for the mechanical engineers, here's your average. Now, let's talk about covering the coldest days. So generally, we size our gear and passive houses to meet the coldest average load, but you oversize your heating system somewhat. And I think similar advice would be wise for a cooling system as well. And Frank, please do jump in. Frank,
Yeah.
actually, I should have just bounced the question to him because he's got more expertise in that area than I do.
Yeah, well, I guess the one thing I would add is that one of the nice things that now with the new PHPP passive house planning package is it has a very simple spreadsheet where you can put in any future climate change number that you want. Like you can say, what is my climate going to do if the overall global temperature goes up by 1 degree, 2 degrees, 3 degrees, and then it will spit out a new climate data set. You can import that data set and recalculate your existing energy model to then see exactly what those future climates could look like for your building. And then you could use that future data to kind of update or revise what you are designing. So yes, we can produce data sets for any future climate that we want. And we are doing that more because yes, the climate is definitely warming already.
Okay, thank you.
Good. So another question, I guess Kevin went over it briefly, maybe just bring it up again. How do we determine the fresh air requirements in the CFM? And I guess we preface this is the way Passive House does it, which is slightly different than the way ASHRAE does it, which seems to be slightly different the way that everyone does it. So the higher number always governs, but the way Passive House does it is, go ahead, Kevin.
Is like this. I'm just going to share my screen back to that slide because it was more important than perhaps I should have given the time for, right? So in the passive house system, there's a 3-part situation. What you do is you calculate the entire volume of the space. So at the top part of the chart there, volume at 2.74 ceiling height, so 2.74 meter ceiling height. So there's the volume in cubic meters. And what you want to see is the air change rate of 0.3 air changes per hour. So you want the entire space to turn over in fresh air every 3 hours. And then, so that's the one part of the test. The second part is you take a look at the kitchen, bathroom, and washroom. So in this case, there's one kitchen, there's 3 bathrooms in the building, and there's 1 water closet, so 1 WC. And that gives you a certain rate based on boost rates of 60 cubic meters per hour for the kitchen, 40 per the bathroom, and 20 for the WC. That might also be a storage room or say a laundry room or something like that. So you add on for that, and then you get a total there, which in this case was 200 cubic meters per hour. Then you talk about the occupants. Now we modeled this at 4 occupants because the owner says, look, that's the partners in the business right now. So model it to there. And then you take the 3-part calculation, you take the most volume out of those 3, which was the volume of the building, right? So if you just do it based on the occupants, it would be under ventilated. You do it just on the basis of the spaces, it would be under ventilated. Think about how this calculation would change though for say a small studio apartment with 2 people. right? Then all of a sudden it's either the most likely either the occupants or the kitchen and the bathroom that are going to dominate the discussion. In this case, it was the volume. So we came up with a number. And then I also calculated the volume of that loft space. That became important, like I said before, mainly in terms of controlling cooling load. So that became important. So we did a volume adjustment, came up with a cubic meter per hour at boost rate and a CFM. And then I talked to Christina and the crew at HVAC Systems, and we chose the system based on those flow rates. So that's how the Passive House standard is. There's a wonderful graphic from one of our courses in Passive House Canada. It's a Venn diagram. It shows ASHRAE and Passive House kind of, or code and Passive House kind of overlapping. And so generally with larger buildings, what we're finding is that a lot of consultants are designing to ASHRAE flow rates and making sure that the flow rates can be dialed down for the Passive House. Now, the ASHRAE system, and Christina, you could hop in whenever, the ASHRAE system, to my knowledge, is done based on quite often intermittent ventilation. That's how the North American model has worked forever, that the ventilation system would turn on and turn off and turn on and turn off. With the exception of a space like a hospital or a gym where it's fairly constant flow is required. Whereas the Passive House system, it's lower flow, but it is continuous. So that may not make a gigantic difference in a large building, but it does in a residence. So anyway, Christina, yes. Please do go.
Sure. So after we will just list based on the building type and usage, it will list the recommended airflow rate, recommended supply airflow rate, and also depending on, usually it's been calculated per occupant as well. So kind of like you said, you're looking at your kind of minimum ventilation, and then you also have to look at your boost ventilation or max ventilation. So we've designed several churches, right? So we want to make sure we have enough ventilation when there's, more than 100 people at that service. So the equipment has to be sized for that, but that's why it's really important to make sure you have a control system in your unit that can adequately decrease that airflow and provide that minimum ventilation at the same efficiency as the high ventilation. Yeah. So.
Yeah, we were so on the verge of using a react damper system. It's just that we weren't going to be able to plan it adequately based on the low occupancy of the building. That's one of the reasons why in this project we backed off on that. But certainly for larger spaces, larger commercial spaces, I mean, even, classrooms, gymnasiums, schools with a classroom and gymnasium, you can see how that kind of variable flow rate heat pump gear would fit so nicely in with variable flow rate ventilation in a space. It's really quite remarkable. So.
It is really remarkable because it's again, you don't need any. Yeah, it's pretty magic as well. But yeah. Mm-hmm.
Hey, well, we're coming up with time, so we have one or two kind of quicker questions. So I guess which is your choice for backup heat, gas, electric, or I guess wood-fired? And maybe is there any specific things that you got to watch out when you're installing heat pumps and ERVs in our colder climates?
Mm-hmm. I mean, my preference would be electrical or wood. Because we're doing Passive House, I don't believe you can have any gas-fired anything in your building.
Can. It just needs to be sealed combustion. I agree. We want to be moving away from natural gas for kind of lots of climate reasons and just going all electric.
Yeah, those would be my preferences, but you guys go ahead.
Well, it depends on the size of your building. And in this case, it was a particular case because it's meant to be off-grid. So there's already sold a really hefty, I think the 128 kilowatt solar array plan for the building, plus a big battery bank. So we're the backup is within the power system already with the batteries. But for backup heating, The wood stove was the fallback. It's on a property that has wood falling out of the sky, so they'd probably be able to heat the building, such an efficient building with what indeed does fall down in the forest. So that's one point. But when you're in a larger center and you've got power failures are milliseconds long, then electric backup is a really good choice.
And in the Swagon unit, if you can also, I didn't mention this, but you can build in your preheat coils or post heat coils. We talked about the changeover coil with the heat pump that was originally integrated into the unit, but we can also do chilled water coils, hot water coils, or electric into the system.
Yeah.
So that can be built into your central ERV. And could that be called, backup heat? Yeah, it is. It's not sized for the unit completely going down, but the chances of that are like 0.2%, I believe, or something. So a lot of designs aren't providing a full backup anymore that I know of.
Yeah, if people are concerned about backup, then what I'm suggesting to clients is that they, particularly if they have a hot water heat pump, then get a small battery that's sized for hot water, ventilation, refrigeration, in other words, your refrigerator, ventilation, refrigeration, your hot water, and a small amount of heating. In a passive house, that is enough to ride you through most power failures, right? Now, if you add a little bit of solar on the roof that's sized only for those backup load situations in combination with a battery, you can have a very inexpensive and efficient system. It might not be a bad idea going forward.
Good. All righty. Well, yeah, lots of questions today. We got through most of them, I think, and we're right at the 1 o'clock time. So yeah, I think we will sign off for today. Thank you all for attending. Thank you for your presentations, Kevin and Christina. And yeah, look forward to some more high performance cold climate passive house buildings built. We're taking December off, so we will see you guys in January for the next Coffee Talk.
Yeah, thanks very much, Frank. That was great. Thanks, Christina.
Thanks, Frank and Kevin, and thanks all for attending. Okay, see you in January.
Yeah.
Okay.
Right on.
Bye.